Hello friends, in this video we are going to ponder about or explore this equation 2y is equal to minus 3x plus 2. You might wonder that this equation does not look like the standard form which we come across. The standard form of a polynomial in first degree is written like this: y is equal to ax plus b, where a is not equal to 0. A is not equal to 0 is specified because once a becomes 0, then there is no x term. And if there is no x term, the equation is no more a polynomial in first degree. It becomes a constant polynomial or a zero polynomial because there is no x term. So now our question is, why doesn't this look like the same? Y is equal to ax plus b. Now it's very easy. You can bring into the standard form by dividing all each of the terms by 2. Now you can divide 2y by 2, it becomes y, minus 3x divided by 2 becomes minus 3 by 2x, and plus 2 by 2 becomes 1. So now this is in a standard form, y is equal to ax plus b. And such equations are called polynomials of first degree. Polynomials of first degree because the variable is raised to the power 1. That's one reason. And another reason is because when we plot it into a graph, you will see that it forms a line. So these are called polynomials of first degree or linear equations. Now, you pause this video for a moment and think of values of x and y which would satisfy this equation. This you try to find coordinates of x and y, which when x is substituted here will give y values correspondingly. Just try to arrive at some coordinates. Here we call y as the dependent variable. We call y as a dependent variable because it depends on the values of x. Y always depends on the values of x, and x can take any random value, so it is called the independent variable because x can be given any random value. So have you arrived at some values? Just write them down. Let me also get some values for x and y. Suppose x was 0. Suppose x was 0. What was the value of y be? y would be minus 3 by 2 into 0 plus 1, or y would be 1. So 0 comma 1 is one value, and let me take 2 for x. Just substitute 2 for x. X being an independent variable can take any random value. So x being 2, y would be minus 3 by 2 multiplied by 2 plus 1, which is minus 3 plus 1, so minus 2. So y would be minus 2. So the coordinate would be 2 comma minus 2. And shall we get, actually two values are enough to get to plot a graph, but let me also take one more value for x. Let x be equal to minus 2. So y would be equal to, this would become positive 3 plus 1. So y would become equal to 4. So this is one more coordinate. Now, by plotting the graph, let us see where this graph intersects the x-axis. The point where the graph intersects the x-axis is called the zero of this linear polynomial. Now just let us try it out. I have a graph ready for you so that we won't waste much time. So this is 0, as you know. X-axis, the x also is 0 here, and y is also 0 at this place. So this is 0 comma 0. This coordinate is called 0 comma 0, and we'll have to plot 0 comma 1 first. So 0 in the x-axis and y in the y-axis. So this is 0 comma 1, this place, and 2 comma minus 2. 2 in the x-axis, 2 in the x-axis, minus 2 in the y-axis. So this position is 2 comma minus 2, and minus 2 comma 4, minus 2 in the x-axis and 4 in the y-axis. So this is minus 2, this being 4, this is the point. This is the point which represents minus 2 comma 4, and this is the point which represents 2 comma minus 2. Now connecting all these coordinates, we get a straight line. See, we have a straight line which goes like this. Now this straight line, you can find for any value of x, you can find a corresponding y value in this line, in this graph of the equation. Suppose you take any random value for x. This is what? This is minus 2, right? X is equal to minus 2. You will be able to find, oh, this is what we have already done, 4. So suppose you take x is equal to minus 1. See, you can find a corresponding value for y. Y would be in between 2 and 3, which is 2.5, 2.5. So if you substitute this value of x as 1, you would get 2.5 in that equation, which you have already arrived at. Y is equal to minus 3 by 2x plus 1. So this graph represents this equation, right? Now, as I spoke about earlier, the zero of this polynomial. What is the zero of the polynomial? The point where the graph intersects the x-axis is called the zero of this polynomial. Why is it called zero? At this point, y takes the value 0. So it can be only one point. So a linear polynomial can have only one zero because the graph will intersect the x-axis only at one point. So this is the zero of the polynomial. So what is this? So let us try to arrive algebraically. Of course, geometrically also you can see what is it, but let us try to arrive at it algebraically. So y is 0 at this point. The equation becomes minus 3 by 2x plus 1 is equal to 0, or minus 3 by 2x, subtracting minus 1 on both sides, you get this, or x is equal to minus 1, x is equal to minus 1 multiplied by 2 by 3, negative of 2 by 3, which is equal to 2 by 3. So you have arrived at the x coordinate algebraically, it is 2 by 3. Here also, if you notice, this is 1 by 3 and this is 2 by 3. So this is the point which is 2 by 3 comma 0. So this is called the zero of the polynomial, right? Zero of the polynomial is the point where the graph intersects the x-axis, and for a linear polynomial there can be only one zero. So I hope you have understood what we have tried to arrive at. Thank you.